Hello everyone, this is Santosh Srivatsav Sharma. We are actually doing a series on three-phase AC systems. So now in the second session, we will discuss what is a three-phase system. I mean, in the previous session, we have discussed why we are using three-phase system all over the world. Now this session is regarding what is actually a three-phase system means. We will discuss all these points in this session. So now what is three-phase system means? A three-phase system consists of three single set of voltages. I mean, if you take a single phase system, it consists of a single voltage. If we take three single such voltages, that is nothing but three-phase system. But we will add few more points to this. A three-phase AC system consists of a three-phase source and a three-phase load. Now what is a three-phase source? What is a three-phase load? What are the three voltages involved? Let us go in detail. Now the three-phase AC source means a three-phase generator. We will get three-phase supply from a three-phase source, and what is the source means? It is three-phase generator. Three-phase generator is otherwise termed as alternator. A three-phase generator or alternator is the three-phase source from which we will get the three-phase AC supply. Now what is three-phase alternator or a three-phase generator? Let us have a brief look on that. Now this is the cross-sectional view. This is the cross-sectional view of three-phase AC generator. What is this? This is an AC machine, and this machine consists of basically it consists of two parts, and this part is stationary part, which we will consider it as, in general we will use armature. This is called stationary part, and this stationary part is armature, and the second part is rotor. This is the rotor part, which is fixed over a shaft and which rotates either in clockwise direction or in counterclockwise direction. A three-phase generator basically consists of two parts. One is stationary part, which we usually take armature as the stationary part, and it consists of rotor. Rotor is a magnetic field system. You can clearly see the north pole and south pole here. In general, this is an electromagnet. I mean, we use a winding on this, and when we excite this winding by using DC supply, I mean when we pass some DC current to it, a magnetic flux is produced and magnetic poles, north pole and south pole, are created. And when this magnetic rotor is rotated, the flux will be rotating, and when the flux rotates, while rotating, this flux cuts the stationary conductors R, Y, B. Here what is R dash means? It is first set of conductor. I mean, R is the starting terminal of conductor 1 and R dash is the finishing terminal of conductor 1. R dash means it is first set of winding. The starting point of winding is R, ending point of winding is R dash, which we connect the ending point to neutral. And if you consider the second set of winding, it is Y dash, and we can clearly see here with respect to 0 degrees, it is placed at an angle 120 degrees with respect to R set of conductor. Second winding is placed at an angle, physically at an angle 120 degrees. I mean, first we place first set of conductor, we will take a physical displacement of 120 degrees, and then we will place the second set of conductor. For the second winding, starting point is Y, ending point is Y dash, and the ending point is connected to a neutral point. Similarly, next again 120 degrees we will take displacement, physical displacement, and we will place third set of conductor. What is the third set of conductor? It is B dash. I mean, B dash is a winding, third winding. So it of 3 windings, R set of winding, Y set of winding placed at an angle 120 degrees and B set of winding placed at an angle 240 degrees with respect to R or 120 degrees with respect to Y. And for the third set of conductor, third set of winding, B is the starting point and B dash is the ending point. Ending point is connected to the neutral point. And now here for this three-phase machine, how does it operates means stationary part consists of 3 windings R dash, Y dash, B dash, which are equally displaced by 120 degrees, equally placed at an angle of 120 degrees. You can take any two set of conductors, any two set of windings, difference is 120 degrees. So now here for this particular three-phase machine, what is this three-phase machine? This is a alternator, three-phase alternator. From this alternator we will get electricity. From this three-phase AC machine we will get three-phase AC supply. Now what is the operation involved? This is stationary part. Stationary part is an armature. It consists of 3 set of windings and we are using circles here. Circle means it is the conductor. We use circle to denote a conductor, winding. And this is a rotor part. And what is this rotor? This is a magnetic field system. Now what is the basic operation here is, we will rotate this rotor by using a shaft. The shaft may be connected to some turbine, some steam turbine or some hydel turbine. This rotor shaft is connected to the turbine. Now if you rotate this rotor, if this rotor rotates, magnetic flux also rotates. While rotating, the magnetic flux cuts the conductors R, Y and B. While rotating, in between the air gap, the flux will be rotating and the rotating flux cuts the stationary conductors. There are 3 conductors, right? The rotating flux cuts the stationary conductors R set of winding, Y set of winding and next B set of winding. And according to Faraday's laws of electromagnetic induction, we will get 3 voltages induced. The voltage induced in first coil is VRN. Voltage induced in second coil is VYN, voltage induced in third coil is VBN. In the first coil, if you take the first coil as reference, so the first coil voltage is VRN, which is a sinusoidal voltage and it starts at 0 degrees. And this is the first set of winding voltage induced in first set of coil which starts at 0 degrees. We have taken R set of winding as the reference. Next, again the flux rotates, induces voltage in second set of conductor after 120 degrees. So that the voltage in the second coil starts at 120 degrees. The second voltage starts at 120 degrees and this is the second induced voltage in the second set of conductor. This is the voltage induced in the second set of conductor. Again with respect to 0, with respect to R set of conductor, the flux rotates and after 240 degrees, voltage gets induced in B winding, third winding. Voltage induced in the third coil starts at 240 degrees and this is the voltage induced in third winding. And these are the 3 voltages induced in 3 windings. And from this sinusoidal waveform, we can write the sinusoidal equations. What are the equations? Voltage induced in first coil is VRN and the instant equation is Vm sin omega t and the voltage induced in second coil is Vyn. Because the voltage is inducing after 120 degrees, the waveform starts at 120 degrees, lagging with respect to 0 degrees, we need to write Vm sin of omega t minus 120 degrees. And similarly, voltage induced in third coil, that is VBN, is Vm sin of omega t minus 240 degrees. I mean third voltage is lagging the first voltage by 240 degrees. I mean the difference between third voltage and first voltage is 240 degrees. Second voltage and first voltage is 120 degrees. We can see this three-phase system as three single-phase voltages system. But the only difference is between any two voltages, the phase angle difference is 120 degrees. Between any two voltages, the voltages are equal in magnitude, whereas the phase angle difference between any two set of voltages is 120 degrees. This is a three-phase AC system. Now here we are going to define one important term, and that important term is phase sequence. Phase sequence is one of the very important term in three-phase AC systems. What is phase sequence? Here if you observe this operation, this magnetic flux is rotating in clockwise direction because we are rotating the magnetic rotor. The magnetic rotor is rotating in clockwise direction, so that the flux is also rotating in clockwise direction. First it induces voltage in R conductor, next it induces voltage in Y conductor, and next it induces voltage in B conductor. I mean, what is the order of induced voltage in the three set of conductors means, first voltage is induced in R, next it is induced in Y, and next it is induced in B. And these are the three voltages, VRN, VYN and VBN. And from this we can define phase sequence as it is the time order, it is the order, it is the sequence. What is the sequence in which the three phase voltages, what are the three phase voltages? VRN, VYN, VBN. And what is the sequence, what is the order? I mean three phase voltages attain their maximum value. I mean, if you consider three phase voltages, what are the three phase voltages? VRN, VYN, VBN. Which voltage reaches maximum value first? Maximum value is reached by VRN first, and next VYN reaches its maximum value, and next VBN reaches its maximum value. And this is the order in which the three voltages reach their maximum values. First voltage VRN reaches its maximum value, and next VYN reaches its maximum value, next VBN reaches its maximum value, because we are rotating the rotor, magnetic rotor, in clockwise direction. When we rotate this rotor in clockwise direction, the flux cuts R conductor first, induces voltage, and next Y conductor and induces voltage, and next the flux cuts the third conductor B and induces voltage. So in this order R, Y, N, the voltages are induced and maximum positive values are reached, and this is the phase sequence. It is the time order in which the three phase voltages attain their maximum values. If you rotate this in clockwise direction, the phase sequence is R, Y, B. Whereas if we rotate it in anti-clockwise direction, I mean if we rotate in counter-clockwise direction, voltage is induced in the sequence R, B, Y. Voltage is induced in first in the R, next in the B, and next finally in the Y. And now the phase sequence is changed. And what is the phase sequence? R, B, Y. We have got only two type of phase sequences. The first type of phase sequence is positive sequence. And what is the positive sequence? In the clockwise rotation of rotor, the voltages are induced in the sequence. The voltages are reaching their maximum voltages, maximum positive voltages in the order R, Y, B. Whereas if you rotate in counterclockwise direction, the sequence changes to R, B, Y. Now the phase sequence depends on direction of rotation of alternator. Based on the direction, we will get this phase sequence. Phase sequence is very important, because if you consider a three-phase motor, if you change the phase sequence, the direction of rotation of motor will also gets changed. So that's why we consider phase sequence as very important parameter. Thanks for watching. In the next session we will discuss three-phase source, balanced source and three-phase balanced load.